Hi, I'm Julia. I am a lab manager and I work in the Chevrette Lab at UW-Madison. We work on bacteria and metabolome, which is basically looking at bacteria and the stuff that they make with computers to try to find new cool stuff that they make. Our research matters outside of academia because one thing that people don't know is that a lot of the pharmaceuticals that we use actually are derived from chemicals that are made by bacteria. So the fact that we are trying to figure out what chemicals bacteria make and how to make the bacteria make those chemicals is actually really important for not only finding new things to treat bacterial infections, but also things like cancer drugs, drugs for immunocompromised folks, so things that are important for organ transplant recipients. A whole variety of drugs are actually derived from things that come from bacteria. People think that bacteria are simple. Actually, a lot of biologists also think that bacteria are simple, and they are not at all. So everything that people do and that larger organisms do, bacteria did it first. They've been doing it for 1 billion years longer than anything else has. They're very adaptable. They adapt to different environmental conditions. They evolve really fast because they grow really fast and replicate really fast. They're a lot more complicated than just a tiny little thing that sucks up nutrients and copies itself. So what drew me to this field is a couple of things. My original research experience when I was an undergrad involved modeling the way that bacteria behave. So I got introduced to research through bacteria, and I stayed with bacteria because I just think that people don't appreciate them that much. They're not understood super well by most people, and I've always liked to study things that are not popular because I think it's more interesting and there's also more room to actually be able to make a contribution. Our work is by default interdisciplinary because we're not just doing microbiology, we're also doing chemistry, and we're also doing a lot of computer-based stuff, so machine learning and handling big data sets. It's basically impossible to do the work that we do without having people coming in from a variety of different fields. I mean, that's really valuable because the way that you're trained to do science in all of those different fields is very different. And so because we have people in our lab who came up as biologists, who came up as chemists, even engineers, we have all of these different perspectives on how to approach problems and how to solve them. So there's lots of different ways that you don't realize until you actually start doing the work, where being in an interdisciplinary space is super helpful. My advice for someone who's just starting out in science, or really anything I guess, is that failure is a necessary step on the path to success. And it sounds pretty trite to say it, but it's not really failure until you stop trying. And 95+% of being in science and being a researcher is failing at things because you're trying to do something that's never been done before. So no one knows how to do it. So you're going to find all of the wrong ways to do it before you find the right way. But then once you find that opens up a whole new set of failures that you can embark on to then find some new thing.